Hello everyone, my name is Shirin Behlim from TYBSC. My roll number is 35. In this video, I will be explaining the topic filtration and use of filter aids. Filtration is an important unit operation in biotechnology and bioprocess engineering. In this presentation, we will understand the definition of filtration, factors affecting it, the use of filter aids, their methods of application, and their limitation. Now, let us start with the definition of filtration. Now, filtration is the process of separating suspended solid particles from liquid by passing a mixture through a porous medium which retains the solids and allow the liquid filtrate to pass through it. In this process, the mixture is passed through a porous medium such as a filter cloth or a filter paper. These solid particles are retained on the filter surfaces as you can see in this photo and forming a layer called as a filter cake. The clear liquid that passes through the filter is known as a filtrate. Filtration is commonly used when solids are insoluble and suspended in a liquid. Now let us see the factors affecting the filtration. The efficiency of and speed of the filtration depends on several important factors which must be considered while designing or selecting a filtration process. First, the property of the filtrate, particularly its viscosity and density. It plays an important role in determining the rate of filtration. Liquids with higher viscosity flow more slowly through the filter medium, resulting in reduced filtration speed. Second, the nature of the solid particles present in the suspension. Significantly, it affects the filtration. Factors such as particle size, shape, size distribution, and packing characteristic. It influences how easily the particle form a filter cake and how permeable that cake will be. Third, the solid to liquid ratio. And this is important because a higher solid content leads to the formation of a thicker filter cake, which increases the resistance to flow and slow down the filtration. The fourth one is filtration is also influenced by the purpose of separation, that is, whether the process is intended to recover the solid fraction, the liquid fraction, or both, as this determine the choice of filtration method and operating conditions. Another important factor is scale of operation and which may be carried out as a batch process or a continuous process depending on the volume of material in industrial requirements. In many pharmaceutical and biotechnological application, aseptic conditions are also essential to prevent the contamination, and these requirements can affect the design and operation of the filtration system. Finally, its application of pressure or vacuum is often used to overcome resistance and ensure an adequate and continuous flow rate of the liquid through filter medium. These are the factors affecting the filtration. Now let us see and understand the diagram of filtration. This diagram shows a basic filtration setup. At the top, we have the slurry, which is a mixture of solid and liquid particles. Below the slurry, a filter cake is formed and as solid and gets trapped on the filter cloth. The filter cloth act as a porous medium. This act as a porous medium, and beneath the filter cloth, the clear liquid called as a filtrate, this passes through and it's collected. And this diagram clearly explains how filtration separates solids from liquid. Now let us continue with the use of filter aids. Filtrates are material added during filtration to improve its efficiency. They are mainly used when the suspension contains very fine or gelatinous particle such as bacteria. Filtrates are especially helpful when filtration becomes slow or when filters get partially blocked. The most common filter aid is Kieselguhr, also known as diatomaceous earth. Filter aids, it increases the porosity of the filter cake, which improves the liquid flow, and the voidage of a good filter aid is approximately 0.85, which indicates high porosity. Now, increased porosity due to filter aids, it leads to higher filtration rate, and the filter rates, it acts as a bridging agent, and it helps in preventing fine particles from blocking the filter pores, and this reduces of the problem called as a blinding which is the wedging of particles inside the pores. The minimum quantity of filter aid required is determined experimentally. However, filter aids like Kieselguhr are costly, and they can absorb some amount of filtrate, which leads to the product loss. Also, some filtrate is lost when the filter cake is discarded. There are three methods of using filter aids. The first method is a thin layer of filter aid. For example, Kieselguhr is applied on the filter medium before filtration, and it's prevent clogging of pores and improve filtrate clarity and flow rate. The second method is the filter aid is mixed with the suspension directly before filtration, and it forms a porous filter cake, and it's useful for very fine and gelatinous particle. The third and the last method is a thick filter aid is used, and mainly in vacuum drum filter the used surface is continuously scraped off and allowing continuous large scale filtration. In limitations of filter rates, there are four limitations. The first one is filter rates are generally not suitable in processes where the main product is microbial biomass, such as yeast or bacterial cells. This is because filter aids like Kieselguhr mixed with the cells and make it difficult to separate and recover pure biomass. As a result, the final product may become contaminated with filter aid particles. And the second one is the cell pre-treatment um, by flocculation or heating may required. In some cases, the cells present in the broth are too small or too fine to be filtered efficiently. Therefore, pre-treatment methods such as flocculation or mild heating are used to make the cells clump together, forming large particles. This pre-treatment involves filtration efficiency but also adds extra steps to the processes. Now, the third limitation is filter aids are not practical when the product is intracellular. Means that when the desired product is present inside the cells, filtration alone is not sufficient. In such cases, the cell must first be broken or lysed to release the intracellular product. Since filter aids are mainly used for separating solids from liquid, they are not practical for intracellular product recovery. The fourth one is removal of filter aid would require an additional purification step. Means after filtration, small amount of filter aid may remain mixed with the filter or product. To obtain a pure product, an additional purification steps is required to remove the filter aid completely, and this increases the cost, time and complexity of the overall processes. These are only the limitations of the filter aids, and this brings us to the end of the presentation. Thank you for watching this video. I hope this explanation helped you understand filtration and the use of filter aids clearly. Thank you.